In this section, we'll look at how to solve equations, both exponential equations and log equations. So there are two methods of solving exponential equations. And the first one is a little bit like what we've already done. That is, get exponents on both sides. The base has to match. So we did this a little bit in section 1 without really even talking about it. So in this problem, we can see that we can rewrite 125. And if you don't, we did this a while back, but if we divide 125 by 5, you get 25. And 25 we can break down into 5 times 5, which means that we can rewrite 125 as 5 to the third. Now because these 5's match, that means that these exponents have to be the same. So we can rewrite the exponents as its own equation. And we can solve that equation. So we add 6 to both sides, and then divide both sides by 3, and we get x is equal to 3. And that solves this problem by making the bases match. So in this problem, we can make the bases match as well. Now we can't change 8 to be 4 times 2 because we can only use exponents. But we can look at 8, and instead of stopping at 4 times 2, we can keep going. And we can see that we have 3 2s, so 8 is 2 to the third. So the left-hand side, we would write it as 2 to the third, and it still has an exponent of x plus 2 on there. Now the right-hand side, we recognize that we can break 4 into 2 times 2, or 2 squared. So we have 2 squared, and it still has an exponent of x minus 3. Now this number has to get multiplied by that exponent. So that means distributing it. So we have 3 times x is 3x, and 3 times 2 is 6. And the same idea over here, we have 2, it has to be distributed. So we would have 2 to the x, 2 times x I mean, and then 2 times 3, which is negative 6. So now, because these 2's, the bases are the same, we can set up our own separate equation with just the exponents. So 3x plus 6 has to equal 2x minus 6. So we would get the x's onto the same side. We'll subtract 2x from both sides. And we get x plus 6 equals negative 6. And then we subtract 6 from this side, from both sides. And that cancels out over here, leaves me with just x equals negative 12. So now we'll look at how to do it if we can't make those exponents match, or the bases match. If we can't make the bases match, then we have to use logs. Remember, logs and exponents undo each other. So we need to get the thing with it has the exponent by itself on one side, and we use a log on both sides. We'll use ln if the base is e. And then simplify by bringing the exponent out in front of the logs. That's that power property that we did a little bit in the last section. And then we'll solve for the variable. So in this problem, we can't make 134 be power 5 to some exponent. So we're going to start by writing log in front of the 5x and log in front of the 134. So we're just inserting log on both sides in front of whatever's there. And then we had a property that said we could bring this out in front. So we'll have x log of 5 equals log of 134. And remember, this means x times log of 5, so the opposite of multiplication is division. We'll divide by log of 5 on both sides. That cancels out, leaves us with x equals. The exact answer would be just exactly what we see here. Log of 134 over log of 5. And sometimes in your homework it will ask for that exact answer, and sometimes it will want the calculator answer, and will tell you where to round it. So to type the calculator answer, you just type in exactly what you see there. Make sure you close your parentheses before you go on. And that would be like about 3.04. And this is rounded. So if the directions tell you to round, then that means they want you to type it into your calculator and get a number. If they want exact, they want you just to write this whole expression, not the x equals part, but just the logs and the parentheses and the division. Let's do another one. So here we can't make 8,000 be 10 to some power, so we're just going to write log in front of both the 10x and in front of the 8,000. And again, that means we can use our power property. We're going to bring that x out in front, so now we have x times log of 10 equals log of 8,000. Now remember, log has a base of 10, right? So that means that this really just cancels out. It's just 1. And actually, so we don't have to do anything else to solve this. It just is equal to log of 8,000. And you can type that into your calculator to get the approximate answer. It would be 3.90. Now you could divide both sides by log of 10, like let's say you didn't realize that this canceled out. That's okay. You could do log of 8,000 divided by log of 10, and you'll get the same answer. So this time we want to find our answer, and it says to 2 decimal places. So the thing in this problem is that we don't have the e with the exponent by itself. That has to be by itself before we can do anything else. So the first thing we'll do is add 5 to both sides. And that leaves 7 times e to the 2x. And 58 plus 5 is 63. And now we have to divide both sides by 7. So there'll be e to the 2x is equal to 9. And now that we have the e with the exponent by itself, now we can use logs on both sides. But when we put logs in on both sides, we're going to use ln because of the e. So we have ln of e to the 2x equals ln of 9. And remember that ln really has a base of e, so this cancels out and we're left with 2x is equal to ln of 9. So we'll divide both sides by 2, and we get x is equal to ln of 9. Close the parentheses, because that 9 was with the ln before the 2 ever got there. Divide by 2. So when you type it in, you have to do ln of 9, close the parentheses, divide by 2, and you should get, it says 2 decimal places, you get 1.0986, and it keeps going. This would be our second decimal place, but this 8 makes this 9 become a 10, so we'd have 1.10 for our answer. So here's another one where we want to solve it to 2 decimal places. And this one's a little tricky because it's got exponents on both sides, but we can't change the 3 and the 7 to make the bases match. So we have to use logs. We're going to put log in front of the left. And we're going to put log in front of the right. And that allows us to bring this out in front of those logs. So now we have 2x minus 1 times log of 3 and x plus 1 times log, let me put the parentheses with the 7 instead, times log of 7. So we have to get the x's onto the same side. So in order to do that, we have to get rid of these parentheses, which means that we have to distribute. So I know it feels a little backwards, but this right here is going to get distributed times both of those. So we have 2x log of 3 minus 1 log of 3. And then we're going to do the same thing over here. This log of 7 is going to get distributed. So we'd have x log of 7 plus log of 7. So now we're going to move the things that have x's to the same side of the equal sign. So I'll subtract x log of 7 from both sides. At the same time, this one doesn't have an x right here, this log of 3. So I want to move it away from the x's. So I'm going to add log of 3 to both sides, and that cancels that out over here. So on the left-hand side, I have 2x log of 3 minus x log of 7 equals log of 7 plus log of 3. So the things that have x's are on one side, the things that don't are on the other side. So let me rewrite this and clean up my space so I have a little bit more room to work. Okay. So now we can see that this has an x and this has an x. So we're going to factor that x out. So we have 2 log of 3 minus, and that x will be gone, so it would just be log of 7 equals this side we're not changing anything with. So now this is really x times all of this, so I can divide by that big long piece on both sides. To get x by itself. So that gives me x is equal to log of 7 plus log of 3 over 2 times log of 3 minus log of 7. Okay, now let's just do the top part in our calculator first. If we do the top part in our calculator, we have log of 7 plus log of 3. Make sure you close your parentheses after each number. And that gives us 1.3222219. We want to write down several numbers because we're in the middle of a problem. On the bottom, we do 2 log of 3, close your parentheses, minus log of 7, close your parentheses. And that gives us 0.109144. So now we can type that into our calculator. 1.3222219 divided by 0.109144. And that gives us, to 2 decimal places, 12.11. So that one's really long and messy. Most of them aren't going to be that long and messy. So this is a note in your notes. It just is to remind you when your homework asks for the solution set, it wants the exact answer, not a calculator answer. So that's going to be important to remember, to pay attention to what it's asking for there. So now we're going to look at log equations. So these are equations that have the word log in it, or ln. And to do this, we have to get the log by itself on one side, and then we'll rewrite it in exponential form. And we did that in 4.2, that's reminding you here. And then we'll solve for the variable, make sure that the solution does not have will not give us a negative number inside the log. So let's look at some examples. So in this problem, the log is already by itself on that side. So we're going to rewrite it in exponential form. So that, remember, that means that we start with the base, and then we go to the other side. That becomes the exponent, and it's equal to what's inside the log, which is x minus 4. So this becomes a problem that we can now solve without anything weird. 2 to the third power is 8. We can add 4 to both sides, and we get 12 is equal to x. Now what we mean by making sure it doesn't give us a negative number is we have to look at this inside piece, this x minus 4. And if I stick this 12 into that spot in place of x, I get a positive number. And as long as that's a positive number, we're fine. If that becomes a negative number, then we have to cross out that answer. So here, this log has a 4 in front of it. That really means 4 times ln of 3x. So we can't do anything until we get that 4 gone. So we're going to divide by 4. And then we can rewrite it in exponential form. Remember that ln tells us really there's an e there. So we'll start with that e. And then we go to the other side to get the 2. And that equals, we go back here to get this 3x. So we'll divide both sides by 3 to get x by itself. And that tells us this x is equal to e squared over 3. And that's the exact answer, or the solution set. To get something else, we could use our calculators. We could type in e to the second power, close your parentheses, divide by 3. And that, if we round it, gives us 2.46. Okay, so in this problem, you can see that we've got log written 2 different times. And we can't solve it when there's a log written 2 different times. We have to smash them together. So here's that plus sign. That means that we can rewrite this as x times x minus 3 equals 1. And then we have to remember that this is a base of 10. So we can rewrite this in exponential form. So we'd have 10 to the first power equals this inside piece, x times x minus 3. So now we have a problem that doesn't have a log in it any longer. We need to distribute this to get rid of the parentheses. And then we want to subtract this 10 from both sides because it's an x squared equation, so it needs to equal 0. And then we can factor this. It factors to x minus 5, x plus 2. Set each piece equal to 0 like we did in the last section, last chapter. And that gives us a 5 and a negative 2. So now we need to check and see, do we get negative numbers inside? So here inside there's an x. And if I put 5 in place of that x, that's fine. But if I put a negative 2 in place of x, that gives me a negative number. So I have to throw out that negative 2. I still have to check that x minus 3. So I put 5 in place of that x, and I get x minus 3 is a positive number. So this 5 works in both those places. and is my answer. Let's do one more in this video. In example 8, we have logs in several places. We're going to leave the left-hand side alone for a minute. But the right-hand side, where there's 2 logs, we want to smash together. So remember that when it's minus, we're going to smash it as division. The one that's first goes on top, and the one that's last goes on the bottom. Now this looks really messy, but because we have a ln on both sides, we can just cross out that ln and work the problem without it. Now to solve this, we're going to put each of these in parentheses so we can keep things together. We're going to multiply by the denominator of this fraction because that will help us get rid of the fraction. And over here on the left, now we're going to multiply. So we have x times x is x squared. X times negative 3 is negative 3x. 1 times x is 1x, and 1 times negative 3 is negative 3. Over here, we'll just keep it for a second. So we can combine some like terms. And because this is an x squared equation, we need to get everything onto the same side. It has to equal 0. So I'm going to subtract 7x, and I'm going to add 23. So that gives me 0 over here, minus x squared minus 9x plus 20 over here. So that can be factored as x minus 4, x minus 5 equals 0. So x minus 4 equals 0, and x minus 5 equals 0. That gives me x equals 4 and x equals 5. So we still need to check that. So we'll start with the x minus 3. If I put 4 in here, I get a positive number. If I put 5 in here, I get a positive number. So that's okay. So then I'm going to check the 7x minus 23. If I put 4 in here, I have 7 times 4 is 28. Minus 23 is positive. If I put 5 in here, 7 times 5 is 35 minus 23 is also positive. So now I have one more. I have x plus 1. So I'll put the 4 in there, and I get a positive number. And I'll put the 5 in there, and I get a positive number. Which means that both of these answers work for this problem.